In this short video, we will learn how to solve a third-degree price discrimination problem when we have a firm with an increasing marginal cost curve. Let's imagine that VertiQuest, a rock climbing school with some market power, faces two distinct demand curves. The demand from locals is given by Q equals 400 minus 0.5p, and the demand from others, non-locals, is given by Q equals 500 minus 0.5p. The firm's marginal cost is equal to 100 plus 2Q, and they have no fixed costs. Now let's suppose that VertiQuest is able to distinguish between the two types of customers and wants to engage in third-degree price discrimination. Our goal is to find the profit maximizing quantity and price for each market. What do we need to know to solve this question? We need to know each market's demand or inverse demand, and we also need to know the firm's marginal cost function. How are we going to solve this question? Well, it turns out because we have an increasing marginal cost, we cannot just set each firm's marginal revenue equal to marginal cost. Instead, we have to apply the optimality condition. And the optimality condition is that the marginal revenue in the local market has to equal the marginal revenue in the other market, has to equal the marginal cost, where we have to be really clear and mention that the total number of units produced and sold by VertiQuest is equal to the sum of what they sell to locals and what they sell to others. Let's solve this question. Here's what we know. We have our two demand curves as well as our marginal cost curve, and we are trying to find the profit maximizing price for each market. We know ultimately we're going to apply that optimality condition, and to apply that optimality condition, we need to find the marginal revenue in each market. We'll start with locals. To find that marginal revenue, we know it's like a three-step process. First, we need inverse demand. Then we can use that to find total revenue. And finally, we can find marginal revenue. So we're going to look at our local demand curve and we're going to invert it, meaning we're solving it for P. So let's see. We have adding 0.5p to both sides. We get 0.5p is equal to 400 minus Q. Multiplying both sides by 2 to get rid of that 0.5, we have P is equal to 800 minus 2Q. Using this inverse demand, we can now find total revenue. Total revenue is going to be a function of Q and is equal to inverse demand times Q. So we can just multiply this thing through by Q, the P function, through by Q, and we get 800 Q minus 2Q squared. Finally, we can find marginal revenue by taking the derivative of total revenue with respect to Q. In this case, that will be 800 minus 4Q. So we need to do that for others next. We're going to quickly repeat the process here, finding inverse demand, total revenue, and marginal revenue for non-locals. So looking at our demand curve for others, we're going to invert it. We have 0.5p is equal to 500 minus Q. Multiplying by 2, we have P is equal to 1,000 minus 2Q. To find total revenue, we multiply our P function by Q and we get 100. Sorry, that should be 1,000, now shouldn't it? 1,000. We get 1,000 Q minus 2Q squared. Finally, now that we fixed our mistake, we can find marginal revenue by taking the derivative of total revenue with respect to Q. That's going to equal 1,000 minus 4Q. So previously we found the inverse demand and marginal revenue for each type in our market. We are now ready to apply that optimality condition, which tells us that the marginal revenue in the local market has to equal the marginal revenue in the other market, which also has to equal the marginal cost of the entire amount produced and sold by VertiQuest. So filling in what we know, we have 800 minus 4QL is equal to 1,000 minus 4QL is equal to our marginal cost. Marginal cost is 100 plus 2Q, and I want you to notice that this Q is QL plus QO, so in place of that Q, I've put that sum right here. From here, it's kind of an overwhelming looking expression, but don't let it frighten you. The simplest thing to do is break this up into two equations and two unknowns. What I mean is you can take the first part, 800 minus 4QL equals 1000 minus 4QO, call that equation 1, and then you can take a different part where we know that 800 minus 4QL also has to equal 100 minus 2 times QL plus QO. So we break it up into two equations, and we should be able to solve this system for both QO and QL. So we're going to start by solving equation 1 for QO. It's not going to be a numerical answer. It's going to be how QO depends on QL. I want you to notice the negative signs on 4QL and 4QO. The first thing I'm going to do is I'm going to swatch those things. So I'm going to rewrite equation 1 as 4QO plus 800 is equal to 1000 plus 4QL. Now I'm looking for QO, so I'm going to now subtract 800 from both sides. So I have 4QO is equal to 200 plus 4QL. And now I divide both sides by 4, and I get that QO is equal to 50 plus QL. And we can call that equation 3. So this must be true in order to meet that optimality condition. Now we are going to take that equation 3 that we just solved for, and we're going to substitute it into equation 2, eliminating QO and allowing us to solve for QL. This is going to take quite a bit of algebra, but we can do it. So we have 800 minus 4QL is equal to 100 plus 2 times QL plus QO, where QO is 50 plus QL. Now we can simplify a little bit. Notice in here, this is 2QL plus 50. Then we can rewrite what we have. 800 minus 4QL is equal to 100 plus 2 times 2QL is 4QL. 2 times 50 is 100. Now we're going to combine all our QLs together. I'm going to do it on the right-hand side of the equation because that will generate a positive term. And we're going to shuffle all of our constants over to the left-hand side of the equation. So I have 800 minus 100 minus another 100, which is 600, is equal to 4QL plus 4QL, which is 8QL. I divide both sides by 8, and I get that QL is equal to 75. So now we know how many units our firm should sell to the local market, and from there it should be quite easy to solve the rest of the problem. Our next step is to substitute that QL equals 75 into equation 3. That's going to allow us to solve for QO, the number of units that VerticWest should sell to the other market. So QO is equal to 50 plus 75, which is 125. So we have successfully applied that optimality condition in order to find that we should sell 75 units or memberships to locals and 125 to others. But we're not done because we still need to find the prices that should be charged. We now need to use the inverse demand curves to find prices. Conveniently, I've put the inverse demand curves over here so we can refer right to those. So the price that we should charge in the local market, PL, is equal to 800 minus 2 times 75. 800 minus 150 is 650. And the price that we should charge in the other market is equal to 1000 minus 2 times 125. 1000 minus 250 is equal to 750. So we have our final solution. Vertiquest should charge locals $650 and others $750. As a result, they will serve 75 locals and 125 others.